Today in this video lecture, we will see numerical on shear connector. Numerical is a wooden beam is prepared by connecting three pieces as shown in the figure. This is one piece, this is second, and this is third piece. And this is one shear connector and this is another shear connector. If the cross section of the beam is subjected to maximum shear force of 100 kN, data in this numerical is cross section of beam subjected to maximum shear force denoted as capital S is equal to 100 kN, and determine the spacing of the connector assuming their shear strength to be 15 kN. So in this numerical they given shear force and shear strength. Shear force denoted as capital S and shear strength in this shear connector denoted as F is equal to 15 kilonewton. And to find spacing T, determine the spacing of the connector assuming their shear strength to be 15 kilonewton. So for solving this numerical, steps are: first to find moment of inertia, second to find shear flow between the junction of two planks, between this wave junction and plane junction. Between this junction we have to find shear flow, and third, with the help of shear strength of one nail formula, we find this spacing. So see step by step this solving methodology for this numerical. First step, moment of inertia. Denoted as I is equal to, see this I section symmetric about x axis and y axis. So first we have to find this whole red color rectangle moment of inertia, and then we subtract this one rectangle and this another rectangle from this red color rectangle. So first finding red color rectangle moment of inertia about this x-axis. X-axis parallel side is 300 mm, 300 as it is, multiply by this depth is 300 plus 150 plus 150 600. So 300 multiply by 600 cube divided by 12 and minus, subtract these two yellow color rectangles. Yellow color rectangle side is this 300 minus 150, 150, and 150 divided by 2 75. That means this side is 75 and this side is also 75. So moment of inertia is 2 into these 2 is for, there are two yellow rectangles, 2 multiply by parallel to this x-axis side is 75. 75 as it is, multiply by 300 cube divided by 12. 75 multiply by 300 cube divided by 12. So moment of inertia is 300 multiplied by 600 cube divided by 12 minus 2 into 75 is 150 multiplied by 300 cube divided by 12 is 5.0625 into 10 raised to 9 mm raised to 4. This is first step, calculation of moment of inertia. Now second step is to find shear flow between the junction of two planks. one plank is this flange and second plank is this web, and between this junction, that means this, second shear flow between the junction of two planks. Shear flow is denoted as Q is equal to SAY upon I. Yes, they have given us in numerical 1000 kilonewton. So 1000 multiplied by 10 raised to 3 Newton multiplied by area for that flange portion is 150 into 300, 45,000. And multiply by y is distance between this x axis and this flange neutral axis distance, this much distance. This much total distance is 300, and 300 minus 75, it is 225. Divided by moment of inertia is 5.0625 into 10 raised to 9. So shear flow between the junction of two planks is 100 into 10 raised to 3 into 45,000 multiplied by 225 divided by 5.0625 multiplied by 10 raised to 9 is 200 Newton per mm. At junction. And next third step is to find pitch distance or spacing. Let P be spacing or pitch. The strength of one nail is shear flow multiplied by spacing. The shear flow is 200 and spacing is denoted as P, and strength of one nail is F. Shear strength to be 15 kilonewton. The spacing of the connector, determine the spacing of the connector assuming their shear strength to be 15 kilonewton. So strength of one nail is 15 into 10 raised to 3 Newton. Therefore this P is equal to 15 into 10 raised to 3 divided by 200. This is 75 mm. Therefore spacing of the connector is 75 mm center to center. So see, once again this numerical. A wooden beam is prepared by 3 pieces as shown in the figure. If the cross section of the beam is subjected to maximum shear force 100 kilonewton, determine the spacing of the connector assuming their shear strength to be 15 kilonewton. Connector shear strength to be 15 kilonewton. and we have to find spacing. So for solving this numerical, we first find out moment of inertia, then we find out shear flow between the junction of the two planks. Shear flow between the junction of the two planks denoted as Q. Q is equal to SAY upon I. So yes, they have given us a numerical 100 into 10 raised to 3. A, we have find this flange area 45,000, and Y is neutral axis between flange and original I section neutral axis, x axis, and this flange axis distance. That means this distance 225 mm, and divided by moment of inertia, we get shear flow between the junction of two planks is 200 Newton per mm. And then with the help of strength of one nail formula, strength of one nail is equal to shear flow into spacing, we find out this P spacing is equal to 75 mm center to center. Thank you very much.